In this lesson, we are going to talk about classification models. For your warm-up journal, I want you to look at the image. How many colors are in the image? Would you say, let's see, 1, 2, 3, 4, or 4? 5, 6, 7. Try finding yellow. Where does yellow start and where does it end? I want you to answer these in your journal. It's kind of a trick question. If you are thinking there's not an exact way to tell where yellow starts or where it ends, then you might be right. If you're thinking along the lines of RGB codes, that's how you would tell where yellow starts and where yellow ends, you would also might be right. There's not necessarily a right or wrong answer. If you could teach a computer to separate these colors, how would you do it? Our key vocabulary for this lesson includes 2 words. Categorical data, which is data that can be separated into groups, and classification, which is predicting a category based on other features. Colors are an example of categorical data, which means they can be grouped into different categories like yellow or green or blue. And when we ask a computer to look at a color and tell us what it is, we're asking the computer to classify which color it belongs to. Classification is something we learn how to do with our senses, but computers must be taught to do. In this lesson, we're going to investigate how computers can use classification to solve problems. We're going to start with a simple example, determining if something is a fruit or vegetable. Our question of the day is, how do computers classify data? So, pay attention because by the end of this lesson, you should be able to answer that question. Let's say you go to a friend's house and they make a meal that you've never eaten before, so you're not sure if you will like it or dislike it. What are some qualities you look for in foods that you think help decide whether you'll like it or dislike it? For example, my husband is 100% anti-celery, cilantro, and green bell peppers. If it has any one of those 3 ingredients in it, he is not gonna like it. All right. I, on the other hand, am a pretty amicable person. I like trying new things, but, I would say there are probably foods from other cultures that I'm not so crazy about. But how would I know? I know I'm not going to try raw oysters. I'm not doing it. Okay, I don't know if I would like it or dislike it, but I know I'm not going to do it. Maybe because of the texture. So if it's slimy, I'm not going to eat it. Okay, if it has literally 0 flavor, I'm not going to eat it. So like oatmeal, but without like the peaches and cream. Okay, it's not going to happen for me. If it is like ghost pepper hot, that's a no. I'm not a fan of soggy fries. So, things like that. But if I can't tell based on its looks or its smell, I'll at least try it. After thinking about this question, we have come up with a bunch of different features of food. These features are things that we can use to help make decisions. In this lesson, we're going to see if we could teach a computer to decide if a food is a fruit or vegetable. For now, we're going to focus on only 2 features, how sweet the food is, and how easy it is to eat. We've also got 20 foods that we can use to train the computer to help it tell the difference between fruits and veggies. You will need to download the documents attached to this assignment post. There are two. You have the activity guide right here, and then you also have the fruit and veggie cards resource. So this fruit and veggie cards resource is going to tell you the sweetness of the fruit or vegetable and the ease of being able to eat it, like how easy it is to eat it. Let's look at the directions on the activity guide. Step 1 is determine how sweet and how easy to eat each food is. If you've never eaten the food before or you're not sure, you can use the recommended values. I would maybe just go ahead and go with the recommended values, even if I don't necessarily agree with them, because, like, let's see, carrots, it's a 10. I mean, you just eat it, right? You don't have to cook it. Watermelons, it's a 10. If this little orange right here is a cutie and it's easy peel, it's like a 9. Okay, as long as you've got like long fingernails. An apple, it's easy to eat. But I'm just going to go with what they have, the numbers that they have put on here. Okay. We're going to keep it simple. You don't have to go with those numbers if you don't want to. Okay. Put a point on the graph for each food. If the food is a fruit, write a small F next to the dot. What I'm going to do is first zoom out, second get my tools, okay, and then we're going to make a dot. Nope, wrong button. There we go. Okie dokie. I am going to start with the apple. This is a fruit. Okay, this is a fruit. And it has a sweetness of 7 and an easiness of eating. Oh, I did get an F on there. Okay, sweetness of 7 and an ease of eating 6. So that's going to go there. And now I am going to center that F. Make it a little bit bigger. Okay, and then I'm just going to copy and paste that. And a banana is a 6 on the sweetness and a 5 on the eat. Okay. And so what I want you to do is I want you to keep going and I want you to completely fill this up, okay? So it says if the food is a veggie, write a small V next to the dot. And when you are finished, you should have 10 fruit dots and 10 veggie dots on your graph. I would probably also make the veggie dots a different color. But pause the video here so that you can complete this activity guide. Now remember, I said you can use the recommended values if you want to, and whenever you get done, we are going to look at a completed graph. Now, you're making a graph here, and so you can actually connect this back to skills that you learn in whatever math class you take. This is the x-axis, the sweetness is the x-axis, and the easy to eat is the y-axis. And so whenever we are looking at the sweetness point number and the eat number, we're looking at an x and a y. And so we're going to find the number on the x-axis, and then we're going to follow that line up to the y-axis. So this right here would be grapes. And I would agree, except unless they have seeds in them. And then it might not be so easy. Might be like a 9. All right. So let's look at our chart. In regards to determining if a fruit or vegetable is a fruit or vegetable, it looks like the sweetness and the easiness to eat are really two pretty good features to focus on. These two features are doing a great job of separating foods into fruits and vegetables. This is really great for a computer. If it wants to determine whether a food is a fruit or vegetable, it just needs to see where it is on the graph. Things that get a little tricky in the middle of the graph, though, so we need to make a decision. How can we divide our graph into a fruit side or a veggie side? So one way we could do it, we see this clear division right here. So we could say this, like down the sweetness level. We could say, take it from this with the, on the pink line, sweetness and ease. We could say with the green and let it be a little more angled a little bit more. So you decide how you would split your graph. And that's going to be another way that we want, that's going to be another thing that you'll do before you submit your activity guide. Pause the video here so that you can divide your graph. What you have just created is a model that we can use to help a computer make a decision. When a computer sees a new food, it will plot a new point on the graph and use that to decide whether it's a fruit or a vegetable. So let's see how our model does with some test foods. All right, so let's get into testing our model. The next several slides have different foods to test against the model. So let's see how well our model does in deciding if something is a fruit or a vegetable. One example we have is a raspberry. So if we put the raspberry at a sweetness of 9 and an ease of eating at a 10, would it be considered a fruit or a vegetable? It would be considered a fruit. Okay, what's next? What about a pumpkin? A pumpkin's sweetness is a number 3, okay? And the ease of eating is a number 2. So that would be right here. And based on that, it would be a vegetable. Next, we have the tomato. A sweetness of 6. I don't know if I agree with that. And ease of eating, a 6. So that technically puts it on the fruit side. You know the age-old debate, is a tomato a fruit or a vegetable? So where does the tomato fall on your chart? All right. I don't think tomatoes are that sweet. I would probably put it on like the 3 for sweetness because like they're pretty acidic. And so that would put it on the vegetable side. But based on these numbers, it's a 6x and a 6y. So this one, you know, tomatoes are technically classified as fruit because they contain seeds, but they are usually used as vegetables when making foods. So where does the tomato fall on your chart if you used your own personal opinions for these numbers? I definitely want you to put that in the discussion board. Okay, what about a cucumber? Sweetness of 5, ease of eating of 4. It's look, honestly, the ease of eating should be like a 10 because like I literally just picked up a little baby cucumber and just ate it. I mean, you rinse it off and then you just take a bite. It's not that difficult. But again, a cucumber is technically considered a fruit because of the seeds. But when we use it like we do fruits. So, no, vegetables when we are preparing food. And I definitely call a cucumber a vegetable. So think about that. Where does it fall on your chart? And then include that on the discussion board, okay? What about a lemon? Sweetness of 2 because it's sour, okay, unless you add some sugar. Ease of eating of 5. But we definitely consider lemons fruit, so that's not quite right. What about a sweet potato? Love sweet potatoes. Okay, sweetness of 7, definitely. Ease of eating 5. But that marks it as a fruit. Based on our model, the lemon is a vegetable and the sweet potato is a fruit, right? Okay, so let's see what's next. Ice cream. Sweetness, 10. Ease of eating, 8. Probably because if you eat it too fast, you'll get a brain freeze. Okay. Ice cream is a fruit. Perfect. What about some Flamin' Hot Cheetos? Sweetness, none. Absolutely none. Ease of eating, 6. That is definitely a number that might not be true for everybody. Okay? So, Cheetos are a vegetable based on our model. So you can see we've got a little bit of a problem when we start using our model, but we can expect that most models will probably get these last 2 answers, technically the last 4 answers, incorrect, which means our foods were misclassified. This happens in real life too. Sometimes models make decisions and get incorrect answers. For something like classifying fruits and vegetables, it may not be a huge deal, but if we're making decisions about people instead, this could be a really big deal. This is why testing is so important. We need to make sure our models are doing a good job before letting them make decisions for us. All right, these last 2 examples are pretty silly, but they are an example of using a model for something other than what it was intended for. Since we trained our model only on fruits and vegetables, it doesn't work very well on other types of foods. If we wanted to improve our model, we'd probably need a lot more data and a lot more features. More than just how sweet and easy to eat food is. This gets a lot harder for us as humans to understand, and we couldn't use our graph paper anymore. Luckily, computers can help us with this. In the next lesson, we will see how a computer looks at lots of data and lots of features to help make decisions. So you have a wrap-up journal, and then you'll need to add the new vocab to your journal slide, your vocab slide in your journal, okay? If you were to break down the process we went through in this lesson to create a model into steps for a computer to follow, how would you describe those steps? And do you now know how classification works?